In this video, we will solve problems from exercise 3.5. Question number 1. Find the value of cos 2a. A lies in the first quadrant when cos a is equal to 15 by 17. So, in the first question, given to us cos a is equal to 15 by 17. So let's consider this right angle triangle A, B, C. Cos A is adjacent side, which will be BC, divided by hypotenuse, which is AC. So from triangle ABC, our AB is equal to square root of AC squared minus BC squared, which is equal to square root of AC is 17. So 17 squared minus 15 squared. So further solving this is equal to 289 minus 225, which will be equal to root of 64, and that is 8. So AB is 8. So sine A will be defined as opposite side by hypotenuse. So AB by AC, which is 8 over 17. Next, let's go to solve cos 2a. That's our ultimate goal of this problem. So cos 2a is given by the formula cos squared a minus sine squared a. Okay, so since we have cos a and sine a, let's replace their values into this. So cos a is 15 by 17. So it's 15 by 17, the whole squared, minus sine a is 8 by 17, the whole squared, which is, we can keep 17 squared as our common denominator, which is 289. And in the numerator, we have 15 squared, which is 225, minus 8 squared, which is 64. So your answer would be 161 divided by 289. Question number 2. Given to us sine A is equal to 4 by 5. And we need to find cos 2a. So what is the formula for cos 2a? Cos 2a can also be written as 1 minus 2 times sine squared a. Okay, so this is an identity. So replacing the value of sine a into this identity, you get this is equal to 1 minus 2 into 4 by 5 square, which will be equal to 1 minus 2 times 16 by 25. And that's equal to 25 as a common denominator. 25 minus 2 times 16 is 32. So that is minus 7 by 25. Therefore, cos 2a is equal to minus 7 by 25. Next to the third part of the question. Question is tan A is equal to 16 by 63. This is given to us. Okay, so if this is given, and we need to find cos 2a. So the definition of cos 2a is given as 1 minus tan squared a divided by 1 plus tan squared a. Alright, so now let's substitute the value of tan a into this. So this is 1 minus 16 by 63 the whole squared divided by 1 plus 16 by 63 the whole square. So this can be further simplified as, in the numerator, if you take 63 squared as the denominator, this will become 63 squared minus 16 squared divided by, again 63 squared will be our denominator here for the denominator, and the numerator of the denominator will be 63 squared plus 16 squared. Okay, so I think our challenge is now to find the values of 63 squared and 16 squared. 63 squared will be 63 times 63, 9 here, 189 here, 18, balance 1, 37. So it's 9693. So that's our 63 squared. And 16 squared we know is 256. So replacing these values, the denominator and the denominator will disappear. So you're left with 3969 minus 256 divided by 3969 plus 256. So now let's work this out. So 3969 minus 256 will be 3713 divided by the sum of these two will be 4225. That's our answer. Question number 2. If theta is an acute angle, then find sine pi by 4 minus pi by 2 when sine theta is given as 1 by 25. So let's take the first part of the question. So given sine theta is equal to 1 by 25. Okay, now the formula that we'll be using here is cos 2 theta is equal to 1 minus 2 sine squared theta. So this can be also written as cos theta is equal to 1 minus 2 sine squared theta by 2. I'm taking, instead of 2 theta, theta. So automatically this theta will become theta by 2. So I can rearrange this expression as sine theta by 2 is equal to, let me take the, rearrange these two on the opposite sides. So this will be 1 minus cos theta divided by 2, the whole square root. Okay, so this is what we're going to be using here. Let's get here. So what we need to find is sine pi by 4 minus theta by 2. This is a very easy problem, just we need to understand. Let's take 1 by 2 out from the denominator, out of the brackets. So this will become sine 1 by 2. If I take 1 by 2 from pi by 4, this will become pi by 2. And if I take 1 by 2 from theta by 2, it will become theta minus theta. Right. Now this is in the form of sine theta by 2. So let's replace this pi by 2 minus theta into this cos theta here. Okay. So it's the same. Instead of theta here, we have pi by 2 minus theta. Okay. So replacing, instead of this theta, pi by 2 minus theta into this theta, cos theta here. So this expression will now become square root of 1 minus cos pi by 2 minus theta divided by 2. Okay. Now we know what is cos pi by 2 minus theta. Cos pi by 2 minus theta will still be in the first quadrant, and it's equal to sine theta. So this is nothing but square root of 1 minus sine theta divided by 2. Now we are given sine theta is equal to 1 by 25. So this will be equal to 1 minus 1 by 25 divided by 2. Since given sine theta is equal to 1 by 25. Okay, so this is now equal to root of 2 in the denominator, 25 minus 1 divided by 25. So this further simplifying, you would get 24 divided by 25 times 2. So this can be further simplified as, this will be 12 and the 2 will disappear. So it's 12 by 25. Again, this is 4 times 3 divided by 25. So 2 squared is 4. So we take the 2 out and we keep the root 3, and 25 squared is 5. So that's our answer. Now for the second part of the question, which is cos pi by 4 plus pi by 2 is what we need to find when sine theta is equal to 8 by 9. So we can say, given sine theta is equal to 8 over 9, and you need to find cos pi by 4 plus theta by 2. Again here, the formula that we would be using is cos 2 theta is equal to 2 cos squared theta minus 1. So we can rewrite this as cos theta is equal to 2 times cos squared theta by 2 minus 1. And again you can rewrite this as cos theta by 2 is equal to, if you take the 1 to the other side, this becomes 1 plus cos theta, then 2 divided by 2, then this is square, so this is a square root. Alright, now let us take 1 by 2 out of the expression here. So this will become cos 1 by 2 into pi by 2 plus theta. Okay, so that's equal to, now this expression here, pi by 2 plus theta, is the same as the theta here. So let's replace this theta inside here with pi by 2 plus theta. So this is equal to square root of 1 plus cos pi by 2 plus theta divided by 2. This is from here. So this is equal to, now, root of 1 plus cos pi by 2 plus theta will be equal to, it's in the second quadrant and cos is negative. So this will be minus sine theta divided by 2. So which is nothing but root of 1 minus sine theta by 2. Sine theta is given to be 8 by 9. So let's replace the value of sine theta here. 1 minus 8 by 9 divided by 2 would be equal to root of 9 minus 8 divided by 9 divided by 2, which is equal to root of 1 by 18. This can be rewritten as square root of 1 by 9 into 2, which is equal to 1 by 3 root 2. That's our answer. Question number 3. If cos theta is equal to 1 by 2 into a plus 1 by a, show that cos 3 theta is equal to 1 by 2 into a cube plus 1 by a cube. So you're given cos theta and you need to show that cos 3 theta is equal to this expression. Okay, so the formula that we would be using here is cos 3 theta is equal to 4 times cos cube theta minus 3 times cos theta. Okay, so this is the expression that we'll be using in this problem. So we need to find cos cube theta first. So to find cos cube theta, given cos theta is equal to half into a plus 1 by a. Therefore, cos cube theta is equal to 1 by 2 cube into a plus 1 by a the whole cube, and that's equal to 1 by 8 into a plus b the whole cube will be a cube plus b cube plus 3ab into a plus b. So this is a cube would be this plus 1 by a the whole cube plus 3 times a into 1 by a into a plus b, which is a plus 1 by a. Okay, so now rearranging this, we get this will get cancelled, so you'll be left with 1 by 8 into a cube plus 1 by a cube plus 3a plus 3 by a. Okay, next let's apply this into our cos 3 theta. That would be equal to 4 times cos cube theta minus 3 cos theta. This is from here. This is a formula. And we have found cos cube theta to be equal to this expression. So let's substitute here. So 4 into 1 by 8 into our expression is a cube plus 1 by a cube plus, we can take the 3 out common, 3 into a plus 1 by a minus 3 times of cos a is half into a plus 1 by a into 1 by 2 into a plus 1 by a. Further rewriting this will get cancelled. This will be a half. So we can take half out as a common, and then inside the bracket we will be left with a cube plus 1 by a cube plus 3 into a plus 1 by a minus, since we've taken the half outside, it's within one bracket, 3 times a plus 1 by a. Now these two expressions will get cancelled. So you will be left with half into a cube plus 1 by a cube. Therefore, LHS is equal to RHS. Hence the proof. Question number 4. Prove that cos 5 theta is equal to 16 into cos to the power 5 theta minus 20 times cos cube theta plus 5 times cos theta. So we need to find cos 5 theta and we need to express that in this form. So we can take LHS, which is cos 5 theta, and break it into cos 3 theta plus 2 theta. We are aware of 3 theta and 2 theta. So we know that cos alpha plus beta would be cos 3 theta cos 2 theta minus sin 3 theta sin 2 theta. So the formulas that we're going to end up using here are cos 3 theta, which is equal to 4 times cos cube theta minus 3 cos theta. Then the second formula that we would use is cos 2 theta is equal to cos squared theta, 2 cos squared theta minus 1. Then sin 3 theta is equal to 3 sin theta minus 4 times sin cube theta. Then sin 2 theta is equal to 2 times sin theta cos theta. So these are the 4 formulas we'll end up using here. So let's apply them onto this. So instead of sin 3 theta, we would say 4 cos cube theta minus 3 cos theta. And instead of cos 2 theta, we will put 2 cos squared theta minus 1, and then sine 3 theta would be 3 sine theta minus 4 times sine cube theta into sine 2 theta would be 2 times sine theta cos theta. Okay, now let's expand this further. So for the first term, we would have 4 times 2 would be 8. Cos cube into cos squared will be cos to the power 5 theta. Then this multiplied by minus 1, this will be minus 4 times cos cube theta. Then minus 3 theta into plus 2 cos squared theta would be minus 6 cos cube theta. Then minus into minus plus 3 cos theta into 1 will be plus 3 cos theta minus, let's multiply this first term with 2 sine theta cos theta. This will be minus 6 sine squared theta cos theta, and then the second expression is minus 4 cos theta, minus 4 sine cube theta into this expression here. Minus into minus will become plus. 4 times 2 is 8. Sine cube into sine theta would be sine to the power 4 theta, and you have a cos theta here. Okay. Now here we can simplify these two expressions. So, and make this 8 cos to the power 5 theta minus 10 cos cube theta plus 3 cos theta, which is the first 4 terms. Then instead of the sine squared theta, let us replace it with 1 minus cos squared theta. So it's minus 6 into 1 minus cos squared theta cos theta plus, let's replace sine to the power 4 theta with 8 into 1 minus cos squared theta to the power whole squared. So this is nothing but sine squared theta to the square, which will be sine to the power 4 theta into cos theta. So again, further simplifying, let's just bring these terms as they are. Cos to the power 5 theta minus 10 cos cube theta plus 3 times cos theta. And now let's expand this. This will be minus 6 cos theta. Minus into minus is plus. 6 times cos squared into cos theta will be cos cube theta plus, let's expand this expression here. So this will be 1 plus cos to the power 4 theta minus 2 times cos squared theta into cos theta. So let's carry all this down as they are. 8 cos to the power 5 theta minus, you have a minus 10 cube and a plus 6 cos cube. Okay, so this will become minus 4 cos cube theta. Then plus 3 and minus 6 will become minus 3 cos theta. And let's expand this further. So this will be 8 into cos theta first. 8 cos theta. Then 8 into cos to the power 4 into cos theta will be plus 8 into cos to the power 5 theta. Then 8 into 2 will be 16 and cos squared 2 into cos theta. So it's minus 16 cos cube theta. Okay, now let's take the similar terms and put them together. So you have cos 5 theta here. So this will be 8 plus 8, 16 cos to the power 5 theta. Then you have a cube term here and here. So minus 16 minus 4 will be minus 20 cos cube theta. Then you have plus 8 and a minus 3. So this will be plus 5 cos theta. This is the same as your RHS. Hence the proof of the problem. Question number 5. Prove that sine 4 alpha is equal to 4 times tan alpha into 1 minus tan squared alpha divided by 1 plus tan squared alpha, the whole square. Okay, to prove this, let's take first the RHS. That would be more easier for us to prove. So RHS is equal to 4 times tan alpha into 1 minus tan squared alpha divided by 1 plus tan squared alpha, the whole square. So this is now, further you can rewrite this as 2 times of 2 tan alpha. I'm taking the, instead of 4, I'm taking the 2 outside the bracket, divided by, and I'm going to take one of the 1 plus tan squared alpha here. 1 plus tan squared alpha into, you have the second expression here, which is 1 minus tan squared alpha divided by 1 plus tan squared alpha. Okay, this is from the denominator. Okay, now if you look at this, this is in the form of sine 2 alpha and this is in the form of cos 2 alpha. So this is nothing but 2 times sine 2 alpha and this is cos 2 alpha. So 2 times of sine 2 alpha and cos 2 alpha is nothing but sine 2 times of 2 alpha, which would be sine 4 alpha, which is equal to the LHS. Hence the proof. Question number 6. If A plus B is equal to 45 degrees, show that 1 plus tan A into 1 plus tan B is equal to 2. So given A plus B is equal to 45 degrees. So we can say tan A plus B is equal to tan 45 degrees, which would mean that tan A plus tan B divided by 1 minus tan A, so tan A, tan B is equal to tan 45 degrees is 1. So this implies tan A plus tan B is equal to, cross multiplying this to the other side, 1 minus tan A tan B. Okay. Now let's take the left hand side, LHS. LHS is 1 plus tan A into 1 plus tan B. Now this is equal to 1 plus tan A plus tan B plus tan A tan B. Now we know that tan A plus tan B is equal to 1 minus tan A tan B. So let's replace this here. 1 plus 1 minus tan A tan B instead of this expression, plus you have a tan A tan B. You can say from 1. Okay. Now further expanding, removing the brackets, you will end up having 1 plus 1 minus tan A tan B plus tan A tan B. So these two expressions will be cancelled. So you're left with 1 plus 1, which is 2. That's equal to RHS. Hence the proof. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.